Hi everyone, this is Senthil. Today we are going to discuss about the topic relation and function in grade 12. Before that, we have to revise some concept from 11th standard. So in the first chapter, we have studied about Cartesian product. So we are going to revise the concept from Cartesian product. First of all, we have to know about the Cartesian products. Generally, Cartesian products defined from sets. Suppose we are considering a set A and B means it is denoted by A cross B. What about the elements of A cross B? It should be in the form of small a comma b, where small a belongs to capital A and small b belongs to capital B. Suppose we are considering a set A having the elements 1, 2, 3 and another set B having the elements 4 and 5. We are taking two elements in B. So if I want to write the elements of A cross B means what we have to do, we have to take every element from A should pair with the second set B. That is all the elements of B. Every element of A should pair with all the elements of B. Here the first element is 1. So 1, 4 and 1, 5. And we have to pair with the second element, that is 2, 4, 2, 5. And take third element, that is 3, 4 and then 3, 5. Okay. So these are the elements of A cross B. Now, how to find the number of elements in A cross B? So here we have some formula for that finding the number of elements in A cross B. What is the formula? N of A cross B equal to N of A into N of B. Right? So here just we have to know the number of elements in set A and B. Here what is the number of elements in A? Here we have 3 elements in A. So N of A equal to 3 and here N of B equal to 2. Just we have to multiply the both numbers to find the number of elements in A cross B. Okay, here we have totally 6 elements. So therefore, N of A cross B having the elements what? 6. Okay, so now we have to know about the relations. So relations. First of all, relation means what? It is also a set of pair elements, right? So set of pair elements, that is simply we can say it is a subset of the Cartesian product. It is a subset of the Cartesian product. So here we have A cross B. So suppose I want to write a relation R means we can take any element from A cross B. We can take 1 element, 2 element, 3 element. Otherwise, we can take all the elements from A cross B. Okay. So suppose I'm going to take 1, 5 and 2, 4. So suppose without expanding the Cartesian product, that is without writing the elements of A cross B, how can we say the R is a relation of A and B? So first of all, we have to confirm whether the relation from where. Here R is a subset of A cross B, that we can know already. Okay. So here the relation is defined from where? The sets A and B. So every pair should be, that is first element of each pair. Here we have 1 and 2. So that 1 and 2 should be an element of the first set A. Here A having the elements 1, 2, 3. So like that we have to check second element of each pair. Here 5 and 4 are the second element of each pair. This is also an element of B. So now therefore we can say R is a relation. Okay. So first of all, we have to check the relation is defined from where. So that then only we can say whether given set ordered pairs is a relation or not. If I want to say R is a relation means the element should be from the Cartesian product. That is, every element, first element of each pair should be from the set A. That is first set. Here we are considering A means the 1 and 2 should be an element of A. Okay. And the second element of each pair should be an element of the second set. Here we are considering set B. So 5 and 4 are the elements of B. Suppose I am going to define a relation on the set A. Set having the elements 4, 5, 6. Okay. Now I am going to define a relation in A. Okay. That is, I am going to write a relation. Suppose I am going to take the relation as R1. R1 is defined on the set A. That means what? That is, we are going to take elements of R1 from A cross A. Okay. So A cross A means what? Just we have to pair the elements of A with the same element, with the same set. That is, here we are having 4, 5, 6. Okay, I'm going to take Cartesian product from A to itself. Okay, so the same dicto we have to do. That is, we have to take 4 and we have to pair with the 4, 5 and then 6. Like that, we have to take 5, pair with the 4, 5, 6. And finally, we have to do the same thing for 6 also. Here, like that, if we write Cartesian product for the set A means we get number of elements, that is n of A cross A, we are having 9. How can we write? That is, here we are having 3 elements, here also we are having 3 elements. So we have to multiply it to get the number of elements in the concerned Cartesian product. Here we are having 9 elements. Suppose I am going to take R1 as 4, 5, 4, 6 and then 5, 5. R1 is defined on what? The set A. Okay. Here R1 is defined on the set A. R1 having the elements 4, 5, 4, 6 and 5, 5. Now we have to check whether R1 is a relation of the set A or not. How to check? We have to take every first element of each pair. Here we have 4, here we have 4 and here we have 5. So 4 and 5, whether the element of A or not? Yes, it is an element of A. So like that, we have to check the second element of each pair, 5 and 6. So it is also an element of A. So therefore, R1 is a relation. Okay. So now you can clear about the topic relation. Okay. Now we are going to check the relation is a equivalent relation or not. How to check for equivalence relation? That is, a relation should be an equivalence relation means it satisfies the some conditions. What are the conditions? First of all, it must satisfy the reflexive. It must satisfy the reflexive. Okay. Reflexive means what? We need some elements in the form of A, A. Okay. A set, that is a relation, should have elements in the form of A, A. And the second condition, symmetry. What is symmetry? That is, if I take any element from R in the form of A, B belongs to R means the reversal element should be in the same relation. That is, here we are considering A, B means, so the reversal element B, A should be belongs to R. Then only we can say the given relation satisfy the symmetry condition. And third one, what about the third one? Transitive. What about transitive? Here, we have to consider two elements from R. So it is in the form of, suppose the first element should be A comma B belongs to R, and we have to consider another element from R. It is in the form of B comma C should be belongs to R. If both elements are present in R means we have to check whether the resultant element, that is A comma C, should be R in R, not. Okay, so if it is in R means we can say the given relation is satisfy the transitive relation. Reflexive means what? Every element, that is a relation should have an element in the form of A comma A. Okay, and symmetric means what? If it is, we have A comma in the form of A comma B belongs to R means we have to check the reversal element B comma A or belongs to R or not. Okay, so transitive means what? We have to consider two elements in the form of A comma B, B comma C. Here we have the first element ended with B. The same should be start from the second element. Okay, suppose we are considering 1 comma 2 belongs to R means the second element should be start from what? 2. Okay, it may be 2 comma 3, 2 comma 1, whatever we can take. So it must be belongs to R. So then only we can say the resultant element. Resultant elements means what? We can cancel both elements. The resultant element should be A comma C belongs to R. Here what we have 1 comma 2, 2 comma 3 means 1 comma 3 should be belongs to R. Okay, then only we can say it is transitive. Okay, a relation is said to be an equivalence relation means it must satisfy three conditions. The one is reflexive, second one symmetric, and third one is transitive. So reflexive means what? The elements should be in the form of A comma A. And symmetric means what? A comma B. If every element of A comma B, there is an reversal element in the form of B comma A belongs to R. Transitive means we have to take two elements from R. Then only we can check about the third element. That is, it should be in the form of A comma B and B comma C. Then only we can check the resultant element A comma C belongs to R or not. Okay, if it is in R means we can say it is transitive. So a relation satisfying these three conditions mean then we can easily say the given relation is the equivalence relation. Okay, now we can see a question from the first exercise. So determine the relation is reflexive, symmetric, and transitive. So the relation is defined in the set A. Here we have the set having the elements. What are the elements? 1, 2, 3, etc. We have up to 14. Defined as the R also defined like that. What is defined? R is equal to, it is in the form of x comma y, that 3x minus y equal to 0. So here every x comma y should satisfy this equation. Then only we can say it is a relation. Okay, the relation is defined on the set where, that is A. So that means that every element should x comma y should be an element of A. So where whatever we can take, that the element, a pair of elements should be, that is x also should be belongs to A and y also should be belongs to A. Okay, both elements should be belongs to A only. Here the relation is defined on the set A. So that we have to confirm whether the elements are in A or not. Okay, now we have to write the ordered pairs. That is, we have to write the relation in rostered form. Rostered form means what? We have to express these numbers, okay, in rostered form. That is, here what we have, that is 3x minus y equal to 0. We can take this equation as y is equal to 3x. We have to take pairs. What are the pairs satisfy this equation? That pair alone we can take for R. Okay, so here we have to take x from A. That is, have A having the element 1, 2, 3, etc. 13 up to 14. Okay. So first of all, we have to check x is equal to 1. So what about y? 3 into 1, what will come? 3. So 1 comma 3 is an element of one of the element of R. So like that we can take x is equal to 2. X is equal to 2 means what? Y is equal to 3 2s are what will come? 6. Suppose we are considering x is equal to 3. X is equal to 3 means what? Just we have to take this element here. So 3 into 3 what will come? 9. So y is equal to what will come? 9. And we can take x is equal to 4 also. So x is equal to 4 means if we substitute that value in the equation, we get what? Y is equal to 3 4s are 12. Suppose we are taking x is equal to 5. So x is equal to 5 means what will come? Y is equal to 3 into 5, 15. But what we have said, that is every element x and y should be belongs to A. So far we have received the element of A only. Okay. So 3, 6, 9, 12 are the elements of A. But here we are getting value for y 15. So 15 is not an element of A. So we cannot consider this one as an element of R. So therefore, hereafter we cannot write any other element for R. That is, we have to take this element, that is R is equal to what we have, that is 1 comma 3. This, okay, and like that we can take 2 comma 6. And we have 3 comma 9 and then 4 comma 12. So these are the elements of R. Now we have to check reflex. It is satisfying the reflexive. It is whether it is satisfying the symmetric transitive. Okay. So first of all, we have to check reflexive. So reflexive means what? This set R should have an element in the form of A comma A. Should have an element in the form of A comma A. Here we have to check the relation is defined from where? A. Okay. A having how many elements? 14 elements. Here all the elements should pair with the same element. So that is R is whether R must satisfy the reflexive means R should have an element 1 comma 1, 2 comma 2, 3 comma 3, like that it must have the elements 14 comma 14 up to the element 14 comma 14. Then only we can say it is a reflexive. So the relation is defined from where? The set A. A having the elements 1, 2, 3, etc. up to 14. So here we don't have any element in R in the form of A comma A. Okay, we have to check the set A, that is elements from A. So all the elements of A should have, it is in the form of 1 comma 1, 2 comma 2, 3 comma 3, etc. 14 comma 14. So if it is all the elements in the form of A comma A are in R means, then only we can say R is reflexive. Here there is no 1 comma 1, 2 comma 2, 3 comma 3. There is no element in R. So therefore it is not reflexive. It is not reflexive. Okay. So there is no element. All elements should be in R. Then only we can say it is reflexive. If any one element is absent in R means we cannot say it is reflexive. Okay. So the set A, all the elements of set A should pair with the same element. So that type of element should be in R. Here there is no element in R. So therefore we can easily say it is not reflexive. Okay. So now we have to discuss about symmetry. So symmetric means what we have discussed. So every element, if there exists an element in the form of A comma B belongs to R means it should be the reversal element should be belongs to R. The reversal element should be belongs to R. we can take any element from R. Here, suppose we are taking 1, 3 belongs to R. What about the reversal element? If we reverse the element, we get what? 3, 1. Whether 3, 1 is an element of R? No, it is not an element of R. So every element of R must satisfy this condition. Here, there is no reversal element for 2, 6, and there is no reversal element for 3, 9. So like that, there is no reversal element for 4, 12. All element of R should satisfy this condition. Okay, so here the first element alone, that is the first element itself, it not satisfy the condition. So therefore, it is not symmetric. Therefore, it is not symmetric. Okay. Now, it is not symmetric. Now we have to check transitive. Transitive means what? Just we have to check. We have to take two elements from R. So it should be in the form of A, B belongs to R and B, C belongs to R. If two elements are in R means then only we can discuss about the third element, whether an element of R or not. Here we have a element, that is here what we have, that is two elements we can take from R. That is here what we have 1, 3 and 3, 9. Here we have two elements. That is how to take the second element. The second element of the first pair, what we have 3. This next pair should start from 3 alone. Okay. So here we have 1, 3 means it must start from 3 means we can take this element, that is 3, 9. Yes, we have in the form of A, B and B, C. What about the resultant element? The 3 and 3 will be cancelled. The remaining element will be 1, 9. That 1, 9 should be belongs to what? That is, it should be belongs to R, but here there is no element in the form of 1, 9 in R. So it is not satisfying the transitive property also. So therefore, it is not transitive. It is not transitive. Okay. So therefore, the given relation is not reflexive, neither symmetric nor transitive. The given relation does not satisfy any one. So therefore, it is not an equivalence relation. Okay. So it is not satisfying the reflexive. It is not satisfying the symmetry. Okay. And not satisfying the transitive also. Okay. So three conditions are failure. Okay. In R. So therefore, it is not an equivalence relation. Right? I think you understand well. If there is any doubt, you can revise the concept. You can get the clarification. Okay. Thank you very much.